Welcome to the video lesson for section 4.8, applications, aka word problems. Let's get started. To begin with, we have a triangle here with sides labeled as A, B, and C, and it's a right triangle. And we're going to look at how we can apply the sine to that. For our reference, we're going to be looking at this bottom left corner. So for the sine function, it's generally opposite of our hypotenuse. If again, I'm starting for this bottom left corner, then my sine function is going to be equal to B over C. If I take this expression and I know that I'm missing my b side, I would just multiply both sides by c, and I can say that c times the sine of theta is equal to b. If instead I want to find my hypotenuse, and I'm starting with this initial expression of sine because I have that information, I could multiply by c and divide by sine, and end up getting that c is equal to b over the sine of theta. So depending on what I have to begin with and what I'm missing, I could take the sine to help me solve for that missing information. Looking at that exact same triangle, we can go about the same process using our cosine. So cosine is normally adjacent over hypotenuse, which means in this situation, it's going to be A over C. If I wanted to solve for my A value, because I know my C and I know the angle, I could go ahead and multiply both sides by C. And then if I were to want to solve for my C value instead, I could divide both sides by cosine to get my final expression here. So again, depending on what we need, we can manipulate the equation to solve for what we're missing. If we do the same thing for the tangent, we can say the tangent of theta is equal to the opposite of the adjacent, and for this triangle, it would be b over a. But when I take that expression and solve for b, I'd multiply both sides by a, giving me this expression. If instead I want to solve for a, I could then divide both sides by the tangent to get my final expression. So again, for our triangles, depending on what we are given and whether we should start with sine, cosine, or tangent, we can manipulate those expressions to finish solving for that missing piece of information. All right, for our triangle here, we're going to go ahead and try and solve for some information. We're going to start by solving for A. So if I'm trying to solve for A, and you look at the given information and then decide, do I use sine, cosine, or tangent? So I know my angle is 25 degrees. I know I have the opposite side, which is 10, and A would be my adjacent side. So if I'm trying to solve for my adjacent side and I know the opposite side, I would start with the tangent. So I would go ahead and set up my expression. I have B over the tangent of theta is equal to A. And if I plug in my information, I get 10 over the tangent of 25 is equal to A, and by solving for A, I get 21.45. Since I now know my A value and I have my B value, I could go ahead and use my Pythagorean theorem to help me solve for C. Just note this is definitely an approximation because I'm using an approximate value for A, so it's not the best way to do it, but it's a way to do it. So when I go ahead and plug things into my Pythagorean formula, we get 10 squared plus 21.45 squared is approximately C squared. And when I solve this, I get that C is approximately 23.67. For our next triangle, I have an A and a B that's missing. If I wanted to try and solve for B to begin with, I have an angle. B is my opposite side, and 15 is my hypotenuse, so I would start with the sine function. Going back to those original triangles, when I was missing my B and wanted to solve for it using the sine, I would go ahead and use the following expression. C times the sine of theta is equal to B, C being my hypotenuse. When I plug everything in, I get 15 times the sine of 56, and when I simplify that, I get that B is 12.44. I want you guys to go ahead and challenge yourself and see if you can come up with the answer for A using whatever method you'd like. Okay, so depending on how you do this, we could start with the cosine if you wanted to, or you could start with the Pythagorean theorem if you wanted to. Regardless of how you do that, you should end up with something approximately 8.38. So again, just going back over these last two examples, we want to look at the information given to us and whether we use sine, cosine, or tangent to help us solve for what's missing. And then if we're looking for sides, we do have that option of using the Pythagorean theorem. Just know that generally it's going to be an approximation for your final answer. All right, for our next triangle, we have two sides. We have 25 and 35. We're missing side B, and we are missing our angles. We can go ahead and solve for side B using our Pythagorean theorem in this case because we have specific or exact integers. So when I set that up and solve for B, we get that B is going to be 24.5. I now need to try and solve for my missing angle, and I don't have anything else to go off of, so I'm going to go with the information I started with, the 25 and the 35, because those are exact values. And when I use my relationships, I notice that the cosine of my angle is equal to 25 over 35. To solve for this, I'm going to take the cosine inverse, or the arc cosine of both sides. And when I do that, I get arc cosine of 25 over 35, or cosine inverse of that same expression, is equal to my angle. And when I finish plugging that into my calculator, we end up getting 44.42 as my missing angle. One thing to note for these problems, please make sure that your calculator is in degree mode. Otherwise, you would get a radian answer and it might not make as much sense. All right, and now for the fun part, our word problems. We have a park ranger in an observation station 50 feet above the ground who spots a fire. If the angle of depression from the ranger to the fire is 5 degrees, how far is the fire from the base of the station? Okay, so I'm going to go ahead and draw our station here. And then our ranger is going to be in our station. There's our ranger. And we have a fire. Our fire is going to be over here. All right, we know that the station is 50 feet above ground. So I'm going to go ahead and indicate that. This is 50. And we have an angle of depression that is 5 degrees. This is one of the hardest parts for people to kind of visualize. Your angle of depression is going to be your line of sight straight out and your line of sight to the object. So in this case, the fire. So this angle here is going to be 5 degrees. We know that the distance to the top of that triangle is 50. So I know this side over here is going to be 50 as well. The question is, how far is the base of the station from the fire? I'm looking for this distance, which would be the same as this portion of my triangle. So that's what I'm missing. In order to solve this, I'm going to take this information, decide if it's sine, cosine, or tangent, set up my expression, and go ahead and solve. Looking at my angle, 5 degrees, 50 is going to be my opposite side, and x is going to be my adjacent side. So I'm going to start with saying that the tangent of 5 degrees is equal to 50 over x. If I wanted to solve this, I would multiply both sides by x. And then I would divide both sides by the tangent of 5. So my expression would be x is equal to 50 divided by the tangent of 5 degrees. And we end up getting for our final answer 571.5 feet, which is how far away the base of the station is from the fire. All right, for our next example, we have from the point on the floor, the angle of elevation to the top of the door is 47 degrees, while the angle of elevation to the ceiling above the door is 59 degrees. If the ceiling is 10 feet above the floor, what is the height of the door? Okay, we've got a lot going on here. So from a point to the top of our door, here's our door, the angle of elevation is 47 degrees. From that same point to the ceiling, the angle of elevation is 59 degrees. And then we know the ceiling is a total of 10 feet. Okay, I'm going to separate these two triangles so we can see things a little more clearly. So for my ceiling, again, this is 59, this is 10. I'll call this x. For my door, this is 47, this is h, and this is actually also x. So what I can do is I can take my first triangle, the one to the top of the ceiling, and help me solve for x, and then use that to help me solve for the height of my door. Okay, let's go ahead and set up an expression here. So for my red triangle, involving all three of that information, we have the tangent. So I have tangent of 59 is equal to 10 over x, which means that x is going to equal the tangent, it's going to equal 10 divided by the tangent of 59. And I'm going to get approximately 6 for my x value. I can now take this value and plug it into my blue triangle because it's the same expression. And then I have the tangent of 47 is equal to h over 6. And if I solve that, then we get 6 times the tangent of 47 is equal to h. So in this case, our door is approximately 6.44 feet. For our last problem, we have a large helium-filled penguin, which is moored at the beginning of a parade, waiting to start. Two cables are attached to the underside of the penguin that make angles of 48 and 40 degrees with the ground and are in the same plane as the perpendicular line, which basically just means we have right triangles. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? Okay, so we have some information here. We want to know how high the penguin is. I know this has a base of x. So I have two triangles here. I have my inside red triangle, and I have my outside blue triangle. I'm going to go ahead and redraw them. So for my outside blue triangle, I know this is 40. I know this is h, and I know my base is going to be x plus 10 because there's that 10 feet between the cables and then the x distance for your other cable as well. For our other triangle, we have an angle 48, we have an h, and we have an x. What I'm going to do is make two expressions, one for each triangle, relating all three pieces of information. So for our first triangle, I would again use tangent because h is the opposite and x is the adjacent. So I have tangent of 48 is going to equal h over x. And then for my other triangle, I would do the same thing. Tangent of 40 is going to equal h over x plus 10. What I can do with each one of these is I can get h by itself by multiplying each expression by its own denominator. So what I mean is I get x times the tangent of 48, which is equal to h. And that's going to equal x plus 10 times the tangent of 40. All right, since both of these expressions equal h, that means they have to equal each other. And I can also go ahead and multiply in tangents of 48 and tangent of 40. So on the left side, if I multiply x by the tangent of 48, then I get 1.11x. And on the right side, if I distribute, then I get 0.839x plus 8.39. If I go ahead and combine like terms and subtract my 0.839x, then I get 0.271x is equal to 8.39. And then dividing both sides by 0.271, we end up getting that x is equal to 30.96 approximately. So what I can do now, I have an x value. I can go ahead and take that value and I can plug it in either here or here to help me finish solving for my height. So if I take that second expression here, I would have 30.96 times the tangent of 48 is equal to h. And that gets me an approximate height of 34.38 feet as the height of my penguin. All right, guys, that does it for the notes for this section. Go ahead and get started on the homework, and good luck.